Question 8. Steve is asked to solve the equation 5 lots of x plus 2 equals 47, and it shows the working out down here, and it says Steve's answer is wrong. What mistake did he make? Well, if we start with 5 lots of x plus 2 equals 47, if we multiply the brackets out, we'd have 5x plus 10, and that's where the mistake was. So he multiplied the brackets, or the bracket, incorrectly. Okay, Liz is asked to solve the equation 3x squared plus 8 equals 83, and her working is shown, and we've got to explain what's wrong with her answer. So if we start with 3x squared plus 8 is 83, we can take 8 from both sides, and that would give us 3x squared equals 75, so this was fine. Then we'd divide both sides by 3, and that would give us x squared is 25, so this is fine also. And then seemingly, if we square root both sides, then x would be 5. However, it could also be negative 5, because negative 5 times negative 5 is the same as negative 5 all squared, which is also 25. So what's wrong with her answer? Well, there's 2 solutions and she's only got one of them, so the other one was missing. Question 9. The functions f and g are such that f of x is 3 lots of x minus 4 and g of x is a fifth of x plus 1. And we've got to work out f of 10. Well, if f of x is 3 lots of x minus 4, then f of 10, we just replace x with 10, use our BIDMAS or calculator if you wish, and we'd get the answer 18. For the next part, we've got to find the inverse of g, i.e. g minus 1 of x. Now, what we can do here is, if we let it equal y, then all we have to do is rearrange that for x, so we could take 1 from both sides, then multiply both sides by 5, and that would give us x equals 5 lots of y minus 1, and for an inverse to actually happen, x has to become y. I don't want to go into too much detail here, but if we have the line y equals x, then if we have a function like so, then basically it will see itself in the mirror y equals x. So if this was, say, g of x, then this function here would be g minus 1 of x, the inverse. So x becomes y because it sees itself in the mirror y equals x. So all we need to do is swap these around here. So we'd have y equals 5 lots of x minus 1, and because x has become y, this y value is not the same as we have here. It's actually representing the inverse now, not g of x as it did originally. So that's the answer to that part B. And then it says, finally, it says, show that f of x is 9x minus 48. Well, we can write this as this. Now, we know what the function f of x is, so we'll remind ourselves of that. Here it is. So 3 lots of x minus 4. So write that down. And what this means is that the function now takes on the function again. So wherever we see an x, we don't write x, we write the function again. So we'd end up with 3 lots of brackets. Now don't forget, here's an x here, so we just write the function again, and then we take away the 4 from here. Okay, so what we've basically done is put the function inside itself again. So the function has taken on itself. And all we do is we just multiply this out. So we'd have 3x minus 12 minus 4, which is 3 lots of 3x minus 16. And you can multiply this out if you want, it doesn't really matter. Well, it does actually, because we've got to show it's this. So luckily for us, we get 9x minus 48, and that's f of x. So hopefully your teachers explained to you how to do inverses. If not, then that's not necessarily for here, because it would take a long time to do the full explanations, but I'm happy to do some videos by request if people think that would be useful. Question 10. There's a lot of words in this question, so we'll do this slowly. It says the population of a city increased by 5.2% for the year 2014. And it says at the beginning of 2015, the population was 1.56 million. Lynn assumes that the population will continue to increase at this 5.2% rate. So if you want to increase something by 5.2%, then you can times it by 1.052. Okay? So if we times that by 1.052, what will that do? Well, that will take us up to the population at the end of 2015, i.e. the beginning of 2016. And if we were to times it by 1.052 again, that would take us to the end of 2016 and therefore the beginning of 2017. So it's this calculation that I need to do on the calculator, and I'll do that now. So we'll have 1560000 times 1.052 to the power 2, and I'll write the numbers on my calculator display. And put in the separating commas. So to three significant figures, then I'm going to have 1, 7, and this would turn to a 3 because this is a 5, 6, 7, 8 or 9. So we can see there that we've got 1,730,000 will be the population to three significant figures. Then it says, use Lynn's assumption to work out the year in which the population of the city will reach 2 million. And I think what I would do is that I would take my unrounded answer and I would just successively times it by 1.052 to add another year's worth of increase. So times 1.052, and that's going to be the end of 2017, so beginning of 2018, and that's the population here, 1.816. So I'm going to times it by 1.052 again, and that's going to be the beginning of 2019, and so here it is, here's the population that I've got. Just going to get rid of that little mistake. Hold on. Let's change this here. So it's 0.24 and times it by 1.052 again. That should bring it over the 2 million mark. So it's reached this at the end of 2019, so the beginning of 2020, and the population here So 2,010,033.509. So that's safely reached the 2 million mark, and so the year is 2020 or 2020. So, if Lynn's assumption about the rate of increase of the population is too low, how might this affect your answer to part B? What I've said here is that if her assumption about the rate of increase of the population is too low, then that means if the percentage growth is more, then the population will reach 2 million quicker. Okay, so if she assumed that the rate of increase of the population is too low, i.e. it's going to be more, then that means it would reach the 2 million mark faster. Okay, so it would definitely be an earlier year than 2020. So it's important to write in a full sentence there. I've abbreviated a few things for you. So there you go, that's that question. Question 11. The cumulative frequency graphs show information about the times taken by 100 male runners and by 100 female runners to finish the London Marathon. It then goes on to ask, a male runner is chosen at random. Find an estimate for the probability that this runner took less than 4 hours. Well, 4 hours is 240 minutes. So if we go to 240 and look at the male graph, the ogive, i.e. the curvy graph, we can see here, if we get our scale right, that it looks to me as it will be 42 out of the 100. So I would write that 42 out of 100. Now, you can cancel that down if you want, but just leave it like that, that'll be fine. So that's our estimate for that. And then let's have a look if there's another part to the question. It then says, use medians and interquartile ranges to compare the distribution of times taken by the male runners with the distribution of times taken by the female runners. Well, using these medians and interquartile ranges, I'm not going to go through this whole thing, I've already done this in advance because it would just take too long. I've tracked the medians for both and written those down, and I've done them in a table here as well for you so you can see them. And then I've gone to the 25 mark, which is the lower quartile, the 75 mark, which is the upper quartile, and then I've done that for males. And I did the difference between 288 and 215 is 73, so that's the interquartile range for males, and I've done the same for females as well. So the way I interpret this question is, when it says comparing the medians and interquartile ranges, what I would do is I'd put it in context, so I would talk about the running of the marathon and I'd look at the times as well. So my first comment is that females take longer to run the marathon, comparing median times, 276 minutes for females versus 252 minutes for males. And then I've also commented on the spread, i.e. the interquartile range, and I've said the spread of times taken to run the marathon is slightly smaller for females, and I said 67 for females versus 73 for males. Although in this context you could argue that they're reasonably similar, so you could probably say that as well. So quite a lot to write in this type of question, but it is worth it for the 4 marks up for grabs here. Question 12. Marie has 25 cards, and each card has a different symbol on it. Marie gives 1 card to Shelley and 1 card to Pauline. How many different ways can Marie do this? Well, not an easy question if you think too hard. But if there's 25 cards, she can give the first card in 25 ways to Shelley, and then can give the next card 24 different ways to Pauline. Because don't forget, Pauline can't have the same card as Shelley. So it's the same kind of principle as probability trees. So if there's 25 ways of doing the first card, having that issued to Shelley, and there's 24 ways to Pauline, the answer is just 25 multiplied by 24, and on the calculator that should give you 600 ways. Of course, if you were to do it like a tree diagram, then you would have 600 different branches at the end to choose from, which would be very time consuming, as you would agree. The next part is, it says there are 12 boys and 10 girls in David's class. David is going to pick 3 different students from his class and write their names in a list in order. That's important. So the order will be boy first. Well, if there's 12 boys, there'll be 12 ways for the first boy. Then girl, so there'll be 10 girls left to choose from. And then boy again, which means there'll be 1 boy already chosen, which means there'll be 11. So that'll be 12 multiplied by 10 multiplied by 11. And on the calculator, that will give you 1,320 ways. Or girl, well, 10 girls in the class, then a boy, well, 12 boys to choose from, and then girl again, well, you've chosen 1 girl, so there'll be 9 left, which is 10 by 12 by 9. And on the calculator, that gives 1,080. So you've got 1,320 ways there, or another 1,080. So in total, you'd have 1,320 and 1,080 more. And that gives 2,400 ways in total. Question 13. It says the number of slugs in a garden T days from now is P subscript T, where P subscript 0, i.e. when our population is started, when T is 0, is 100 slugs. And then there's an iterative formula where to get the next amount of slugs we have to multiply the previous amount, population, by 1.06. So if we set T to be 0, then we'd have P1, i.e. the first iteration, will be 1.06 times P0. And that's okay, because we know what P0 is. It's 100, which is given in the question. So that gives 106 slugs for P1. So if we want P2, we just set T to be 1 now. So P subscript 2 will be 1.06 times P1, and that's given. So we've got 1.06, well, it's not so much given, we've found it, so we can use that. I'm going to use my calculator here. So I've got 1.06 times 106, and that gives me 112.36. And then P3, where T is 3 days from now, will be 1.06 times P2, which is 1.06 times this value here, and times that by 1.06, and that gives me 119.1016. But as it wants the number of slugs, I'll go to the nearest whole slug, and that would be 119 slugs. Question 14. It says here that D is directly proportional to the cube of n. Mary says that when n is doubled, the value of D is multiplied by 6. Mary is wrong, and we've got to explain why. Well, let's have a look at this in more detail. If n is doubled, n would turn to be twice as much as it was originally, i.e. 2n. So that means D would then be proportional to 2n all cubed, which is 2n multiplied by itself again. So yes, we have the n cubed here, but what do we have here? We have 2 times 2 times 2, which is not 6, it's actually 8. So D would be proportional to 8n cubed. So it seems to me that when n is doubled, the value of D is actually multiplied by 8, not 6. So you can do your explanation, and that's your good reason as to why Mary is wrong. Question 15. It says here that Carol runs in a race. The graph shows her speed in meters per second, t seconds after the start of the race. And you have to try and calculate an estimate for the gradient of the graph when t equals 4. So when t equals 4, we want to estimate a gradient. Now a way of doing that is to just draw a tangent to the curve at that point. So I'm going to give that a try. And then here we go. So there's my effort. And of course it's not going to be perfect, and that's why it's an estimate. Now, if I want to work out the gradient of that, I've got to do the change in y over the change in x, like dy dx. And so one way of looking at that is to try and see somewhere reasonably nice on here where it crosses. I'll go from this point here and I'll make a triangle, and I'll go to, say, this point here. Then all I've got to do is work out the scale here. So I've got 2, and this is 9. So this is going to be 2 from there to there. And then I've got another 1 here, and then a 0.2. So altogether this would be 3.2 in terms of the y. And then the x here, well, from here to here, that's easy, that's a 1, and then I've got another 1 here, and then this is 0.2, 0.4, 0.6. So I've got from here to here is 2.6. So my gradient of the line will be 3.2 divided by 2.6, and I can do that on my calculator. So 3.2 divided by 2.6, and that gives me 1.230769 recurring. And it says here you must show how you got your answer. Well, that's how I've got mine. Well, the next part of the question says describe fully what your answer to part A represents. Well, if I look at the dimensions, I have meters per second here, per second here, because I'm dividing, which is per. So meters per second, which is velocity, by seconds, which is time, and velocity, the rate of change of velocity per time is the acceleration. So what I've got to have here is I'm looking at the acceleration at t equals 4 seconds. The last part of the question says explain why your answer to part A is only an estimate. Well, I think I alluded to that at the very beginning. It depends how accurate your tangent is. So for example, if you were to use a pencil, you could draw it quite thinly, and then you could just put your ruler close to the curve, slide the ruler down so it just hits the curve at the point you want, i.e. this point here, and then you can use a sharp pencil to draw a fine line which just skims the curve at that point. If you use a biro or something thicker, or you move your ruler slightly, then of course you're going to have a slight inaccuracy. You can never be too accurate with these kind of methods, they're just an approximation. But then just don't be clumsy with the ruler and try and have a sharp pencil, and you'll be reasonably accurate. And they'll give you a tolerance in the exam anyway, so you'd have to be pretty bad to get it wrong. So that's the reason. Depends how accurate your tangent is. your tangent is, okay, and how you construct it. So that's the answer to part C. Question 16. It says find the value of, and then we can use our calculator. So I would rewrite this to help you. And then to the power a fifth. Now, if you have this, that means the cube root, the fourth root, the fifth root, which should not be confused with to the power 3, to the power 4, to the power 5, which are the inverses. Okay? So they're inverses of each other. So if you have x squared, the inverse of squaring is square rooting, and we don't usually write a little 2 there, we just put the square root sign. If you want to cube something, then its inverse is cube root, and so on. So to do this on the calculator, I would type in 3.2 times 10 to the power 11, and then do to the power 0.2. If you do 1/5, then you must put a bracket, 1 divide by 5, and then close the bracket with the power button depending on your calculator. So I'm going to do that now. So I'm going to open the bracket, 3.2 times 10 to the power 11, close bracket, and then do to the power 0.2. Sometimes you don't need the brackets, but I'm just going to play safe and just hope that this is okay. So for some reason I just pressed delete by mistake. So 3.2 times 10 to the power 11, close bracket, to the power 0.2, and I actually get 200 as my answer. Part 2 says find the value of 10 to the power 3/4 to 1 decimal place. Well, we know that 10 to the power 0 is 1, and 10 to the power 1 is 10, and so 10 to the power 3/4, which is the same as 10 to the power 0.75, will lie between 1 and 10. So we know that for sure, just in case we make a mistake. So we're just going to do 10 to the power. Now if you wanted to write the 3/4 in, you do 10 to the power bracket 3 divided by 4, close bracket, and we would get 5.623413252. So to 1 decimal place, 5.6 to 1 decimal place. Whereas if you wanted to decimalize, you could just do 10 to the power 0.75. You don't need the 0, and you'd get the same answer. So be flexible with your use of the calculator and you'll be fine. Question 17. It says A is given as 8.3 centimetres correct to the nearest millimetre, and B is given as 6.1 centimetres correct to the nearest millimetre. And we've got to calculate the upper bound, or the greatest possible bound, for C. Well, looking at this, the connection between C, B and A is using Pythagoras. So C squared plus B squared would be A squared, which means C squared would be A squared minus B squared. So C would be the square root of A squared minus B squared. So to make C the most possible, we want the difference between these two to be the greatest, because then when we square root it, it's going to be the greatest possible value it could have been. What we don't want is this to be the least value. So how are we going to make that the most? So we'll call that the upper bound. And to make that the most, we'd want A to be its most, and we'd want to take away the least. So we want A to be the upper bound and B to be the lower bound. So we can go from there. Now, if it's the nearest millimetre, well, how many millimetres are there in a centimetre? Well, there's 10. So if we converted 8.3 centimetres to 83 millimetres, if it's the nearest millimetre, then we cut the millimetre in half, and we can add a half and take away a half either side. So the greatest it would be is 83.5 millimetres, and the least it would be 82.5 millimetres. So if we wanted that back in centimetres, then we can say A, and don't forget we want that to be the most, would be 8.35 millimetres. So that's the value of A we're going to choose. Now we want B to be its lowest bound, so if you think of the same situation, convert to millimetres if it helps. It's to the nearest millimetre, so cut that millimetre in half, like we did before, add half a millimetre to make it the most, take half a millimetre to make it its least. So I hope you can see there that the value of B that we want is going to be 6.05 millimetres. And then all I need to do is put that into my calculator. So we're going to have 8.35 squared minus 6.05 squared and then square root. So let's give that a try. So 8.35 squared minus 6.05 squared and then I'm going to square root that now. And what I get is 5.754997828. Now personally, I'd leave my answer as this, the calculator display, and I'd put the answer here as centimetres. So quite a complicated question there, because you could have thought that you used the upper bound here, but you just got to think, if you want the greatest amount as an answer, you've got to get the greatest amount out from the possibilities for A and B, and that is very difficult, especially when you've got division concerned. In this case we only had a bit of squaring and some taking away, so it wasn't too bad. Question 18. Here we have two brackets that we've got to expand and simplify fully, and I'm going to do this using a grid. And I'm going to put my root A and then root 4b here, and then my root A minus 2 root b here. One thing I've noticed though is that if I have root 4b, that's the same as root 4 times the square root of b, which is 2 root b. So I think I'm just going to change that part here and call it root A plus 2 root b. So I'm just going to multiply these out now. So root A times root A, that just gives me A, and then I've got root A times 2 root b. Well, that's 2 root A root b, and you could also write that as 2 root AB. Doesn't really matter, as long as you've got a rough idea of what's going on. You can write it in a couple of different ways. This one would be minus 2 root A root b, and this last one would be minus, because we've got a plus times a minus, minus 4b, because root b times root b, that's b to the half times b to the half. You add the powers and you get b to the power 1, which is b. So what we can do is now we can look at how these here cancel out with each other, so that's fine, and we're just left with a minus 4b. Now one other idea here is, if your algebra is really good and you've spotted this, which is root A plus root 4b, don't forget we said is 2 root b, times exactly the same but a minus in the middle, then that's like a difference of 2 squares, because don't forget a squared minus b squared is a plus b times a minus b. So if a was your root a and b was your 2 root b, then if you use this formula, a squared minus b squared, i.e. this squared minus this squared, then that would give you the answer straight away. And you'd see that root a all squared is just a, and this all squared is just going to give you 4b. So there was two ways of looking at that, but if you're not really confident, then use a grid. That's absolutely fine. So a minus 4b is the answer. Question 19. It says sketch the graph of y equals cosine x, where x is between 0 and 360 inclusive. Well, if you're not very good at the unit circle, I've got some videos in the library on YouTube under the unit circle trigonometry, which you can have a look at. But if we draw the unit circle here, then if we've got the angle here, x degrees, then we can work out from the unit circle what the values of cos of 0, 90, 180 and so on are. So we'll start with 0 degrees. Well, 0 degrees, then the cosine is 1, because this is a unit circle, so the radius is 1 in all directions. So we've got 1 here, and then importantly I'm going to put minus 1 down here. So the first value is 1. When we turn through 90 degrees, then we actually don't have any length or breadth here at all on the cosine. So when we get to this value here, the cosine has disappeared and it is 0. When we get to 180 degrees here, then we have this situation going on here. So the cosine, if this is 0 and this is negative, don't forget, we'll have negative 1. If we go to 270 degrees, then we have this situation here and there's no cosine at all. And 360 degrees all the way round, we're back to where we started and we're back to 1 again. So all we have to do is join these up carefully. So not a brilliant diagram there, but you get the idea. It's nice and curved, there's no sharp points, although it looks like there is a little bit here, but it shouldn't be. And the nice thing about cosine is it's purely symmetric around the y-axis, so that would just carry off in this direction here, even though we're not going to show that for this particular part of the question. So that's in that interval there, between 0 and 360 inclusive, and if you're not sure of the unit circle, then you could have just used your calculator and typed in cos of 0, cos 90 and so on in degrees, and you'd have got the same values on your calculator. So let's have a look at the next part. It says for part B, the graph of y equals f of x is shown on both grids below. So there's two different ones here. So there's this part and there's this part. It says, on this grid, draw the graph of 2 f of x. Well, what does that mean? It means that y is now twice what it was before. So that means the y values are doubled and the x values stay the same. So if we take an x value at negative 3, the y value was 1, but it's now going to be 2. At this value here, the y value is 1, that's also going to be 2. This value here is 3, so when x is 0, so it's now going to be 6 up here, and these ones are going to follow suit. So this is what my diagram would look like in this situation. And of course, what that has done for me is that it's a stretch by a factor of 2 in the y-axis. Okay, so I hope you can see that there. Now let's move on to the next part. It says, on the grid below, draw the graph of y equals f of x minus 3. Well, if we had f of x shown, x now must become x minus 3. So whether you can remember this or not, this means that all the values on the graph move forward 3 units parallel to the x-axis. So 1, 2, 3, there's the first one, 1, 2, 3, and so on. And then all I do is join these points up. That's a bit untidy, sorry for that. And then this one here. Okay, so notice for each of these questions I chose points which were known originally. I didn't try moving a point, say here, even though that would work as well. You want it so it's on a nice intersection of 2 points, so you've got a nice clear diagram. And I did that for both parts. So that's the end of that particular question. Question 20. Quite a difficult question by the looks of it, so we have to take this reasonably slowly. Well, we have a regular pentagon here, and we also have a circle with centre 0 as well. So we've got to just show that ST is the same as UT. Well, let's have a think about this. I think the first thing is, if this was my centre of my pentagon, then first of all I'd work out what one of these angles here was, and one of those will be 108, won't it? Because if I have this centre here, then if it's a regular pentagon, I divide the 360 by 5, and that would make this 72. It's an isosceles triangle, which would make these 54 each, making this one 108. So that's the first thing I would think about. So each of these are 108. So I'll just label them here. There you go, there's 2 of them. Now the next thing to think about is, it says that QR and PT are tangent to the circle. So that's quite important, because tangents to a circle are at 90 degrees to a radius. So I know that these 2 angles here are 90 degrees. What I'm beginning to think about now is, working my way around this shape, and I use green here, is I can now work out this angle, because I've got 1, 2, 3 sides here that are the same because it's regular, and then I've got these 2 that are radii. So that makes a 5-sided shape. A pentagon, it's not a regular one, but the angles inside the pentagon must add up to the same, and the angles inside a pentagon, well, if it has 5 sides, then it's 3 triangles worth. You can use the formula n minus 2 times 180, or you can just take a 5-sided shape, and then you can just split it up into 3 triangles. There you go, 3 of them. So we know that if we take the 108 and this 108 and the 2 90s, which is 180, and add those up, we get 396, which means that this angle here must be what's left to make 540. Don't forget 3 lots of 180. So that angle there is 144 degrees. And that would mean that if this centre angle is 144, then the angle at the circumference will be half as much. So this angle here is 72 degrees. Now, the nice thing about this is that when we have our regular pentagon here, because these are 108, then this is 108 as well, which means that that angle must be 72. Why? Because angles on a straight line add up to 180. So we've done it now, because we've got base angles here, and therefore it's an isosceles triangle which forces this length to be the same as this length. Therefore ST equals UT. So I haven't written anything down there, and in an exam you would try and write down some things like angles in a triangle add up to 180, angles in a pentagon, internal angles add up to 540, angles on a straight line are 180, and so on. You wouldn't just write all of this here because you may lose a mark. So try and write some brief sentences as well in words to justify your workings. But that's the way around this problem, and I hope you understood it. Question 21. Quite a difficult question here involving ratios. We've got this ratio here, and we're told that it's the same as this ratio here. Well, what I'm going to do is I'm going to get this as a unitary ratio, so I'm going to make one of the sides 1, and I'll divide both sides by 2x minus 1 actually, to make the left hand side 1. So that gives me 1 to x minus 4 over 2x minus 1. And then I'm going to take this ratio here and make the left hand side 1 as well. So I'm going to have 16x plus 1 to 2x minus 1, and I'm going to divide both sides by 16x plus 1. And that makes the left hand side again 1, and that's really good, because if the left hand side of this is 1 and the left hand side of this is 1, that means that this and this are in the same ratio. So I can write 2x minus 1 over 16x plus 1 is going to be the same as x minus 4 over 2x minus 1. Now, that I found reasonably difficult. Now, if I multiply this out to solve for x, then I can do some cross multiplication. If you're not okay with that, then you need to look at some of my other videos on algebra. But if you are, then if we times both sides by 2x minus 1, we'll have 2x minus 1 squared, and then times both sides by 16x plus 1. That's what we have. Multiply this out, so we'll have 4x squared minus 4x plus 1, and then multiply these out, we'll have 16x squared plus x minus 64x minus 4. Now, just checking my work again, I can see a mistake. X times 16x is 16x squared. So let's get the x squares on both sides. So I can take 4x squared from both sides, and that gives me 12x squared here. I'm just going to simplify the right hand side here. I'm now going to add 4x to both sides. And that will give me 1 equals 12x squared. And then if I add 4x to minus 63x, that gives me minus 59x minus 4, and then take 1 from both sides. That gives me 12x squared minus 59x minus 5. Now I think that's quite difficult, because it does say here find the possible values of x. So we've got a quadratic. We're hoping that we're not going to have to use completing the square or the formula. So I'm going to check out the factors of 12, and then the factors of 5, thank goodness, are just 5 and 1. And I want to make the number 59 or negative 59 somehow. Well, I can see it here, because if I do 12 times 5 and 1 times 1, I can make this negative 60 and add 1, and I'll get negative 59. So what I can do here is I can create my two brackets, and I can say a 12x here will go with a 5 negatively, and an x here will go with a 1 positively. So I'll have 12x plus 1 times x minus 5, and if I solve that equal to 0, it means that this could be 0, which means x could be negative 1/12, or this could be 0, and the only thing to make this 0 is when x is 5. So that'd be my two solutions. So quite a difficult question there.